Okay, guys, this is a video how-tos for R9, position, velocity, acceleration, and if you listen to the audio recording, I talk about this there. So let's move on to the first example. Okay, so this example has a position function, and they want you to find the velocity and acceleration at t equals 5. So let's spend some time making sure we really write out what the person needs to see. So we want the velocity and acceleration at t equals 5, and so we're going to start with velocity, and we'd say v of t, and say what it is x prime of t, and that's equal to, and then go ahead and just go for it, 3t squared minus 22t plus 24. And then at, well, okay, so let's just do v of 5 right now. And that's equal to 3 times 25 minus 22 times 5 plus 24. So that's 75 minus 110 plus 24. And so you get v of 5 is equal to negative 11. So then you'll start with a of t, and you'll say that that is v prime of t, or you could even say x prime prime of t, really showing what you know here. Remember, it's all about showing what you know. And that's equal to 6t minus 22. And then so a of 5 is equal to 30 minus 22, which equals 8. And there's no question in my mind that somehow they're going to test you on those two things. So just make sure you understand it. It's not difficult at all, just derivative stuff. All right, let's move on to example 2. You're given another position function, and you're told it's time after 0, and they want the point at which the particle changes direction. And how do we know when the particle changes direction? Particle changes direction when velocity changes sign. Now, you cannot just find where velocity equals 0 and say that's true. You have to make sure that it actually changes direction and it doesn't just stay the same. For instance, if you had end behavior and you were like this, you can see it's changing direction here, here, and here, and here. But what if it looked like this, and it came down and it just touched? Well, this is still negative, negative, and negative, and not till positive here. So this would count, though. You would get this point right here as a critical point. So that's why you always have to look at the sign chart. For this one, you take the velocity, so you would say v of t is equal to x prime of t, which is equal to 3t squared minus 24t plus 36. You set that equal to 0. Let's factor out a 3, t squared minus 8t plus 12. Don't forget your baby algebra. And you get 3 t minus 6 and t minus 2. And so let's do a sign chart for this right here. That would be at 2 and 6. So it would come up like this. So they want it for greater than 0, so it's positive between 0 and 2, negative between 2 and 6. And then positive from 6 on, so it changes direction at, so let's just say that, the particle changes direction at t equals 2 and t equals 6. All right, that's exactly what it asked for, so we're done with number 2. And so we'll stop this video, go on to the next one for 3 and 4.